Hi, everyone. Today is the first of a series of several, videos I'm going to create dealing with Chapter 9 for us, uh, all part of systems of equations. Uh, so this is the first one. I sent out a quick review the other day with respect to how to solve 2x2 and 3x3 systems using graphing for 2x2s and using also algebraic techniques for both types of systems. Let's take a look at how we can do, all size matrices with our calculator. We're going to focus on 3x3s, but this is all size. So let's take a look. Okay. So let me find it here. There we go. Couldn't find it for a minute. So I sent this out. This is a document I prepared for you. Hopefully, hopefully it answers some of your questions. I tried to get as good a pictures of the calculator as I can. These are pretty good pictures. They're not always as good, but I guess luck was on my side this time. So using the matricey features of the TI-83 or 84 calculator. So to solve equations using the TI-83 or 84 calculator, the system of equations needs to be placed in what's called an augmented matrix. The augmented matrix can be input into the calculator, which will convert it to reduced row echelon form. This is called RREF on your calculator. From this form, we can interpret the solution to the system of equations. So we're going to start off with the system of equations. X plus 3y plus 5z equals 7. 2x plus 4y plus 6z equal 8, and 3x plus 9y plus 7z equal 12. In augmented form, what we do for the augmented matrix, if we look at this first row, okay, the very first row here, we have 1, 3, 5, and 7. And so those are the coefficients for x, y, and z, and the answer, the result. So think about this first column as being an x column. These are all the coefficients for x. Think about the second column as being the y column. Those are all the coefficients for y. Think about this third column as being the z column. Those are all the coefficients for z. And then think about this last column in an augmented matrix as being actually the result or answer column for the equation. If an equation is missing some kind of variable, whoops, we'll put a 0 there. So in other words, if there was no 4y here, there'd be a 0 here in that y column. Okay. So now let's start on our matrix, home window. So we're going to press TI-83 or 84, it's similar, they're all the same process. Step 1, to access the matrix features of your calculator, you need to press the shift key, so the second key, and inverse key, that's the x minus 1 key. Okay. So that would be, going back up here, that would be this key right here. See how it says matrix above it? That's what we're pressing. Okay. And then we have a bunch of names. Some of these might have numbers next to them, the A, B, C, D. Yeah, no big deal. We're going to edit. Okay. What we're going to do is second step, we're going to press our arrow key over to edit. Make sure it's highlighted. Then we're going to select the matrix by using the down arrow. So typically, we'll use matrix A, the first matrix. Press enter and edit the matrix. You will see it'll ask you the number of rows and columns. The number of rows comes first. The number of rows would be the number of equations we have, which would be 3. The number of columns would be the number of variables we have, plus the result column, so that would be 4. When the matrix is entered in step 5, okay, so we have this entered in step 5. You can't see the result here because it runs off the screen. It's okay, it's still there. If you arrowed over with your calculator, you would find, if you had your cursor, say, in this first row, and you'd arrow over, you'd see the result. Okay. The screen can only, again, display 3 columns, so again, don't sweat it. So step 6, now that the matrix is entered into the calculator, the reduced echelon form of our matrix is needed. To have the calculator complete the operation, use the matrix menu again So we're going to press second and quit. We're going to get out of there. Okay. Then we're going to press second and matrix. Okay. And then we're going to arrow over to math this time. See where math is see where math is highlighted there? And then we're going to either up arrow or down arrow to this RREF. Now there's the REF. We don't want that. We want the RREF, this item B here. It should be item B on your calculator as well. If it's not, some calculators are aged a little differently. They're programmed slightly differently. And so if it's not item B, just make sure it says RREF. Now, once you highlight that and press enter, it'll take it back to the home screen. So you'll see RREF on the home screen. You will have to tell the calculator which matrix to use. And so to choose the matrix, this is our final part of the process. We go back to second and matrix. And then if we used A, we just, under names, hit enter. So it should look like that when you're done. Close off the parenthesis, it should look like that, this middle picture. Then when you press enter, this last picture will look like this. Now, what does that mean? Exactly, that means that, remember, this is the X column. So we have 1X, 0Y, 0Z. So X equals minus 0.875. Second row, we have 0X, 1Y, 0Z equal 0.75. And then the third row, 0X, 0Y, 1Z equals 1.125. I can now press second, or I'm sorry, it's just a math key, not second, the math key, sorry about that, and enter, and it changes these to fractions, which is useful. So again, interpreting the result, not to beat a dead horse, but the result, once we get this in, that's 1X equals minus 7/8, 1Y equals 3/4, and Z equals 9/8. When we have an independent system of equations, okay, versus a dependent system of equations versus an inconsistent system of equations, how do we know which is which? Well, when we have all ones in this diagonal part, that's when 0 is above and below it, that's called the reduced row echelon form, or RREF. When we get in that form, where there's ones in each one of the rows in this diagonal, and 0 is above and below, and we have numbers here, that basically means that it's an independent solution. All three equations meet up at a single point of A, B, C in this case. What does a dependent solution mean? Remember, the dependent solution is when, basically they're all the same thing. Okay? Remember, with lines, they were the same line. Okay? Just a little bit written a little bit differently. So when we have a system that's dependent, or there's infinitely many solutions, okay, it looks like this. We have a 1, 0, and then a number. And then on the other side, in that answer column, we have another number. Then we have a 0, 1, a third number, and then in the answer column, we have a fourth number. And then the last row is all zeros. Now remember, this is X, Y, and then Z should be down here. There's no Z. Okay, so we'll talk about that in a minute. But this means X plus some number equals B. Now, how do we get that number? So what we do is we parameterize it. How do we parameterize it? It's a dirty word from last week, isn't it? Okay, so we parameterize it. One way we can is just say Z equals Z. Since the zeros are in the Z column, we just say Z equals Z. And at A and C here, those are also in the Z column. So that means basically, if I move this A over, and since it's in the Z column, it'll have to have a Z attached to it. X will equal minus AZ plus the B. I'm going to move the C over with the C attached to it because it has a Z attached to it. And that gives us minus CZ equals D. And then Z equals Z. Or we could parameterize it with T instead of Z and saying Z equals T. So put a T by the C and put a T by the I. And then when we have an inconsistent or no solution scenario, this is where all three planes are parallel, just like both lines were parallel. We have 1s and 1 and then 0 here. 0 is above and below. And then there's something other than 0 here in this third column. So that means 0 equals 1, and that can't happen. Therefore, there's no solution. Okay, so hopefully this helps you out when you're doing your 3x3s. I'd like you to do a couple by hand. Just try a couple by hand, but then, you can use your calculator too, so practice it both ways. We'll take care, and hopefully this helps you. Have a good day.